Welcome back to Pre-Calculus Unit 9. Today we are going to do Learning Target 9.a. This is Lesson 2 in your notes packet, and the learning target is to graph vectors and identify components. So vectors are a very visual way of representing mathematical quantities, so we want to be able to graph and visualize these in a few different ways. So the easiest way to graph or represent a vector is in terms of its initial and terminal points. So we're letting points A, B, C, and D being defined as follows. Point A is -4, 1. So to the left 4, up 1, and that's already labeled for you right there. Point B is 5, 4. So to the right 5 and up 4. Point C is -2, -3. So that is down here. And then point D is 2, -4. So over 2, down 4. So those points are given to you in terms of their x and y coordinates, and they're already plotted for you on the graph. Then we want to sketch the graph of the following vectors. And the first one that we're asked to find is vector t. Remember that the bold-face type here tells you that it's a vector and not just a variable. And vector t is defined as the vector that goes from point A to point B. So all you have to do is go from the initial point at A to the terminal point at B in a straight line and show the direction using an arrow. So that would be vector t defined by points A and B. The second one that we're asked to graph is vector u. Again, the bold-faced letter U tells me that it's a vector and not just a variable. And that is the vector that goes from initial point C to terminal point D. And again, I can tell that it goes from C to D instead of the other way around because of the arrow over top. So starting at point C, ending at point D, and drawing the arrow here, that would be the graph of vector U. Vector V is the vector from point A to point C. So starting at point A, ending at point C, that would be this vector or this arrow right here. That is vector V. And lastly, we're asked to graph vector W, which goes from point D to point C. So you'll notice here that vector U and vector W are very similar. But they are going in opposite directions. So vector U is going from point C to point D. Vector W is going from point D back to point C. So that's why the arrow on top of the initial and terminal points is important, because it tells you which direction you're going in, which one is the starting point and which one is the ending point. Because both vectors u and w, they have the same length, they have the same magnitude, but their directions are opposite of each other. So these are not the same vector. So that is how you would represent, or one way of representing vectors graphically. And once you have the arrow drawn, the magnitude of the vector would just be whatever the length of that arrow is, and the directionality or the angle is just whatever direction the arrow is pointing in. Now, we want to standardize vectors a little bit. So instead of having these arrows drawn all over the graph, that could be rather inconvenient if you started and ended at some large numbers. We're going to stick these onto the origin. So a vector is in standard position when its initial point is the origin. So remember that I said in the last video, the vector is the same as long as it has the same length and the same direction, no matter where it starts and ends. So we are going to be picking up these vectors and moving them so that by default they start at the origin. And this is also known as component form. So you might see a problem talking about putting a vector in standard position. You might also see the problem talking about the component form of the vector. That all means the same thing. So vectors in standard position may be represented by the coordinates of their terminal point using angle brackets. So we need a starting point and we need a stopping point. If the vector is in standard position, then we know where the starting point is. The starting point is always at the origin. So then the only other piece of information you need is the terminal point. And you got to be careful with your notation here. If you see something in parentheses, something like 2, 3, that is a point on the coordinate plane with an x value of 2 and a y value of 3. If you see the same thing drawn inside of brackets, those brackets are yet another way of indicating that this is a vector. So if you see something like bracket 2, 3, you can just type that in if you need to. It's the same as the greater than and less than signs. But this represents not just a point on the plane, but a vector that starts at the origin and ends at that point on the graph. And we can calculate where the terminal point of a vector is going to be with or without graphing it. So if we have some vector v that starts at point P and ends at point Q, so vector v is equal to PQ, and if we have an initial point, px coordinate, py coordinate, and a terminal point with the x and the y coordinates labeled q, then we can find the standard position by subtracting. And this would be the terminal point minus the initial point. Notice that it's subtracting the x coordinates, q minus p, and subtracting the y coordinates, q minus p. So this is terminal minus initial. So let's take a look at some examples and try to visualize this. The first part is just sketching the graphs of some vectors that are represented in standard position. So as soon as you see the angle brackets, those tell you that the initial point is automatically the origin. So instead of needing to go from point P to point Q where both points are given, we know that for all three of these vectors, the starting point is going to be right at the origin. And then the second point that's written inside the brackets tells us where to end. So for point R, my terminal point is at 4, -2. So we would go to the right 4, down 2. There's the terminal point. And then drawing in the arrow, that would be vector R. Vector V in standard position, so the initial point again is at the origin, and the terminal point is given by -3, 5. So it would go to the left 3, up 5. There's my terminal point, and so the vector connecting those two right there would be vector V. And then lastly we have vector Q, where it's in brackets, so that tells me that the initial point is at the origin, and the terminal point is at 3, 4. So over 3, up 4. And connecting the dots, that would be how one represents vector Q. So moving on or moving back, these are the same 4 points that we used in our first example at the beginning of the lesson. We've got points A, B, C, and D. They're defined and they're plotted on the graph. We want to find and sketch each of the following vectors in standard position. So the first one that we're given is vector U, which is defined as the vector that goes from point C to point D. So as it's given on the graph, from point C to point D, vector U looks like that. Now that vector is not in standard position. So we want to draw an arrow that has the same length and the same direction, but that starts at the origin instead of starting at point C. So to do this, let's think about the x and the y displacement. To get from point C to point D, we went down 1 unit and to the right 1, 2, 3, 4 units. So if we want to draw the same vector starting at the origin, we would place our starting point at the origin and then go down 1 unit and to the right 1, 2, 3, 4 units. And then connecting the dots, that would also represent vector U, but now drawn in its standard position. You can see that both of those arrows have the same length and the same direction. It's just been moved to that standard position starting at the origin. And now we can represent this in terms of your standard position notation using our angle brackets, because the initial point is at the origin and my terminal point is here at 4, -1. We'll do the same thing for vector v, which is defined as the vector that goes from point A to point C. So from A to C is this vector right here. This is vector v. So again, if we want to move this to the center of the graph, to the starting point at the origin, we have to think about how far down and how far over does this arrow go. So starting at point A, I have a displacement 1, 2, 3, 4 units down and 2 units to the right. So if I want to sketch that same graph in standard position, I would start at the origin and go 1, 2, 3, 4 units down and 1, 2 units to the right. And this graph here would also represent vector v, just now in standard position. And once it's in standard position, we can represent it using angle brackets and the coordinates of that terminal point. And it looks like it ends, just happens to be at point D, but that has an x coordinate of 2 and a y coordinate of -4. So in standard notation, vector v is bracket 2, -4 and bracket. The last example of this would be vector t, which is the vector from point A to point B. So this is going to be kind of a long one. It's the vector running all the way across from point A to point B. And this has a displacement, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 units to the right and 1, 2, 3 units up. So if I want to draw the same vector starting at the origin, I'm going to go off the graph a little bit, but that's okay. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 units to the right and 1, 2, 3 units up. So there would be my new terminal point. And that's a little crooked, but that approximately represents vector t in standard position. And since that terminal point is 9 units to the right and 3 units up from the origin, 9, 3 would represent that angle in standard form, or that vector in standard form. So that shows you, graphically speaking, how to put an angle in standard position. We are basically picking it up and moving it so that instead of starting at some random point like C or A, we are starting consistently at the origin. We can also find these same sets of coordinates by doing a calculation without plotting any graph at all. And to do that, we have to remember our little formula that if we have an initial point P, and we describe that with an x coordinate and a y coordinate, and our terminal point Q described by, we'll say, Q sub x and Q sub y, then the vector from P to Q is given by the terminal point minus the initial point. So the x coordinates, it would be Q sub x minus P sub x, and then for the y coordinate, Q sub y minus P sub y. So for instance, if I have a vector with initial point -3, -5, and terminal point 5, 1. So the initial point, this is P. Terminal point, this is Q. So the P sub x is -3, the P sub y is -5, Q sub x is 5, and Q sub y is 1. Then the vector from P to Q will be given by 5 minus negative 3, comma, 1 minus negative 5. And then all you have to do to get that as a nice tidy little standard form vector, 5 minus negative 3 is 5 plus 3 or 8. And 1 minus negative 5 is 1 plus 5 or 6. So it's telling us that to go from point P to point Q is 8 units to the right and 6 units up. So in standard position, if you were to start at the origin, then you would end at the point 8, 6. And we can label these with points other than P and Q. And this one, it's A and B. So this would be point A sub x is 2, A sub y is negative 5, the x coordinate of point B is negative 1, and the y coordinate of point B is negative 9. So the vector that goes from point A to point B, again, you're always going to do terminal minus initial, so it would be A or B minus A. So we'll do the x coordinates first, negative 1 minus 2, and then the y coordinates, negative 9 minus negative 5, and then combining like terms, negative 1 minus 2 is negative 3, and negative 9 minus negative 5 is the same as negative 9 plus 5, or negative 4. So basically what this tells us is that to get from point A to point B, it's 3 units to the left and 4 units down. So if you were to start at the origin, then you would end up at the point negative 3, negative 4. And last we have vector HG. So be careful here which is the initial point and which is the terminal point. This is G sub x, this is G sub y, this is H sub x, this is H sub y. And they're giving you G first and then H, but it's asking you to find the vector that goes from point H to point G. So when you're doing terminal minus initial, it will be G minus H. So the vector from H to G, terminal minus initial, we will do 1 minus 7, and then for the y coordinates 4 minus negative 5, and we end up with the vector negative 6, 9. So to get from point H to point G is 6 units to the left and 9 units up. So if you were to start at the origin, then the terminal point would be at negative 6, 9. So that is it for this first lesson. You want to know how to be able to graph a vector if you're given the initial and the terminal point, or if you're given it in standard position. And you also want to be able to calculate where the standard position is given the points, even if you don't sketch a graph. And now there's nothing wrong with checking your work by plotting a graph, but you want to be able to do it computationally and graphically.